Welcome to our video for Chapter 2, Concept 7. This is going to be the last lesson in Chapter 2. You know that Miss Roback likes to end every chapter with some word problems, so we're just going to jump right into things. Linear applications, just a fancy word for word problems. So I've highlighted 3 problems that I'm going to do today in the video, and the other 3 obviously are going to be your responsibility. So let's start over here with number 88. The perimeter of Tina's rectangular garden, so we're talking about a rectangle here, is 60 feet. So right off the bat, as I'm reading this, any information that becomes apparent to me, I'm going to write it over here on the side. So perimeter is going to be equal to 60 feet. If the length of the garden is twice the width, what are the dimensions of the garden? Dimensions means the length and the width. You need to find the length and the width. So the length of the garden is twice the width. What does twice the width mean? Length equals 2 times the width. Okay. So before I go forward with any of this, I'm going to draw myself a little image, a little picture, so that I can see what's going on here. So Tina's got a rectangular garden. And here we have our length and our width, length and our width. Now we should know by now that perimeter means the length around this object, okay? So the length going all the way around Tina's garden. So what that means is we're going to have to add up each side. So for perimeter, we would have a formula of width plus length plus width plus length. We need to add up all the sides. Okay, so now that we have our formula for perimeter, we're going to take all the information that we know, the information that was given to us in the problem, and we're going to substitute it into the formula and then solve from there. So we already said that we know the perimeter is 60, so we can put that in for P equals width plus length, width plus length. For our 2 lengths, we're going to substitute this in because we already said that the length is equal to 2 times the width. So width plus 2 width plus width plus 2 times the width. Okay, and by doing this, now we have all of the same variable. All these are like terms, so we can combine like terms. I want you to stop right here, pause the video, and solve this equation on your own. Okay, hopefully you got the width to be equal to 10. However, we're not done yet because we need to know the dimensions of the garden, and that means both dimensions. Right now, we only found the width. So how can we find the length? Well, right here, we said that length is going to be twice the width. So if we know the width is 10, then that must mean that the length is 2 times 10. So length is going to be equal to 20. Okay. Let's move on to 90. Mike has just opened his new computer store. He makes $27 on every computer that he sells. Okay, let's stop here and like we did in number 88, let's write any information that we're given. Right. So we know from reading the problem that for every computer he sells, he's going to make $27. So I'm going to write $27 per computer. Let's keep going. His monthly expenses are $10,000. So we want to know what's the minimum amount of computers that he needs to sell in 1 month in order to make a profit. Well, each month his expenses are $10,000. So to be making a profit, he needs to make more than $10,000 on selling his computers. Okay. Now, our problem doesn't say how much of a profit, so a profit could be $10,001. That's still a profit because it's bigger than 10,000. Does that make sense? So, like I said, it doesn't necessarily need to be a huge profit, but any profit at all will do for this problem. So, we're going to set up an equation. We want 27 computers to be equal to $10,000 at the minimum, and then we'll see where we are from there. So 27 per computer, so for each computer you get $27, multiply these two things, and we don't know how many computers, that's the variable we need to solve for, so I'm putting in a C, equals 10,000. Now this is just a one-step equation. I want you to pause the video again and try to solve this one. Okay, hopefully you got 370 computers, 0.4. You probably got 0.37 or 0.3 something, but you need to round to the nearest tenth, okay? Now, this is almost 0.5, and we know that 0.5 means half. So this is going to be a little bit under half of a computer. Can you sell anybody half of a computer? If you went to the computer store and they tried to sell you half of a computer, wouldn't you look at them like they were crazy? So we need to round this up to the nearest whole computer. We can't round it down to just an even 370 because that'll be under $10,000. Okay, so we want to make a profit. So let's round it up to the nearest whole computer. 371. So to answer our question, in order to make a profit, he needs to at least sell 371 computers. And we can check that math by plugging in 371 to our original equation up here at the top that I'm going to highlight in blue. Okay, so if we plug that back into here, and I'll show you what I mean. If we, let me zoom out just a little bit if I can. Okay, so if we were to say that he only sold 370 and that would make a profit, well, let's check what would happen if we did that. 370 times $27, because he gets $27 for each computer. See, that's not $10,000. That is only $9,990. So he comes in under his monthly expenses and therefore doesn't make a profit. But if we do 371 times 27, oh hey look, $10,017. Okay, so that is a profit because it's $17 above his expenses. Okay, so that is a plausible answer for us. Let's move on to the last one, number 91. Max and Tina went on a trip and they took turns driving. During her turn, Tina drove 4 hours more than Max, but Max took 2 turns and Tina only took 1. So let's make an equation for the information we know from that. We know that Tina drove 4 hours more than, remember that word more than, okay? So that's going to be whatever Max drove plus 4. And I'm using T for Tina, M for Max. So let's keep reading. Together they drove for 28 hours. So we want a total of 28 hours. While looking at the problem, we know that Max took 2 turns and Tina took 1 turn. So if I was going to create an equation for a total of 28 hours, it would be equal to whatever Max drove times 2 because he took 2 turns. So 2 times Max, 2 times whatever Max drove. And Tina only took 1 turn, so plus whatever Tina drove. All right. So now remember up here, I have T equals M plus 4. I'm going to plug that into this T so that I can solve. Okay. So we have 28 equals 2M plus M plus 4. Okay. So 28 now is going to be equal to 3M plus 4. I want you to pause the video and finish solving this 2-step equation on your own. Okay, hopefully you got that Max drove 8 hours. Okay, but your M in this problem represents one of Max's turns, because remember right here we had to multiply it by 2 to represent 2 terms. So just 1M is 1 term, or 1 turn. How do we figure out how much total that Max drove? This is only one of his turns. He drove for another 8 hours for his second turn, and we want the total hours. So we're going to have to just multiply this by 2. 8 hours the first time, 8 hours the second time. So a total of Max drove 16 hours. Okay. All right, the other three problems are yours to finish. You've got 87, 89, and 92 down here. Give them a try, and when you come to class on Monday, we will go over these and practice with some more word problems so that you're ready for your test.